PN junction and diodes. To increase the practical utility of a P or N-type semiconductor, a PN junction is created in the semiconductor crystal. Here, one half is P-type and the other is N-type. PN junction is the arrangement obtained when a P-type semiconductor is joined to an N-type semiconductor. Displayed here is a PN junction. Immediately after it is formed, the P region contains holes which are mobile and negatively charged impurity ions, which are immobile, and the N region contains positively charged impurity ions, which are immobile and mobile electrons. Many electronic devices use PN junctions. PN junction. As soon as a PN junction is formed, electrons from N-type material and holes from P-type material diffuse into P-type and N-type material respectively. The electrons and holes diffusing towards each other combine near the junction. Each recombination eliminates an electron and a hole. As a result, the positive donor ions in the N region and the negative acceptor ions in the P region are left uncompensated, and this region forms the depletion region. The region of a PN junction containing the uncompensated acceptor and donor ions is known as the depletion region. This region is named so because it is depleted of mobile charge carriers. The holes trying to enter the P region are repelled by the uncompensated positive charge on the donor ions, and the electrons trying to enter the N region are repelled by the uncompensated negative charge on the acceptor ions. As a result, potential difference is established across the junction. Soon, it becomes large enough to prevent any further movement of charge carriers. This is called potential barrier or junction barrier or height of the barrier. From the figure, you can clearly see that the potential barrier VO that is set up gives rise to an electric field that prevents the respective majority carriers from crossing the barrier region. Now, let us see what happens when the negative terminal of the battery is connected to P-type region and positive terminal to the N-type region. Observe whether there is any reflection in the ammeter. As no current flows through the circuit, the ammeter reading is 0. This is because the negative electrons in the N-type region get attracted to the positive terminal of the battery, and the positive holes in the P-type silicon get attracted to the negative terminal of the battery. That is, the reverse bias removes the majority carriers, thus increasing the potential barrier. Current flows through the junction if the PN junction is connected to the battery as shown here. Holes and free electrons enter the depletion region due to repulsion at the respective terminals. The reduction of the potential difference and the width of this region causes a large number of majority charge carriers to diffuse across the junction. Holes travel to the right and electrons to the left, constituting a current in the same direction. Thus, the PN junction allows current carriers to flow through it if the junction is forward biased. A device that allows the current flow only in one direction is called a diode. Thus, PN junction can be described as a diode.